So I've shown this figure before and other things, so I was going to save you the surprise of having different things pop up. But essentially, this concept of cumulative effects as it relates to watershed values is something that we deal with at the water program and other places. We tend to break it up into watershed processes, so the hydrology, the sediment processes, the riparian and channel processes, and then sort of biotic processes. And then we have things in Alberta that operate in our forested watersheds, which can cause effects and make things change. So, forestry can harvest trees, which can affect the flows. They build roads. The flows can affect the channel and the riparian and so on. It's a myriad of interactions and things going on. We also have these sort of pseudo-external forces, whether natural disturbance, wildfire, mountain pine beetle, apparently this pesky little climate change issue as well. So these are all causing things to change our watersheds, to put pressures and change the processes. We tend to break this into more of a logical bin of processes. This is something that Rich McCleary put together a few years ago, actually when we were working with Lee Benda on a different project in southern Alberta. But really looking at, in this case, he's broken it into erosion, riparian, and hydrology processes as far as things on the landscape, on how we think about watersheds, and then the interactions among them, and also sort of our anthropogenic and other impacts associated with them. So this is generally the framework that we've been working with for, about 5 years, as far as how we think about our forested watersheds and how we behave within them and how the interactions work. One of the first things that we did was we actually went through and looked at how other groups assess their watersheds. This isn't new. There's a lot of work that's been going on watershed assessment or analysis, depending on where you are in the world. So we don't really want to reinvent the wheel. I think someone pointed out maybe we can borrow from other ideas or work with other people that have been working on these issues for a while. We sort of published in this pseudo journal ideas on those bins. So we have some on road and surface erosion, riparian health, and flow was another one that came up. There was a few that we put out. Out of this big review, really what we came up with, and I'll go into this a little bit more, was we wanted to base assessments on risk. So sort of the hazard and consequence idea. We wanted to have two levels, so an office and a detailed. A detailed primarily being field-based, but unless you haven't been here or you've been asleep all day, we happen to have a lot of good data in Alberta. I think it starts with an L. So given that we have a lot of really good LiDAR data, one of our big goals has really been trying to merge this field with the office. So can we do a better job of our office-based assessments based on a lot of the investments we've been putting into remote sense data? And then this watershed processes, which I've been talking about a fair bit. So how do the erosion processes work, the riparian processes, and then flow, changes to the flow regime. If we're looking at processes, it makes sense to kind of break this into different bins of processes that we have in the province. So conceptually, we've been looking at purple smudges, which are sort of our east slopes and mountains, blue smudges, which are our foothills, and then the rest. So to date, we've sort of ignored the boreal plains and a few others. There's lots of reasons why we've done that. We haven't ignored it. We've just put our focus on generally where water flows downhill, and if you put something in the water, it moves to an area where it might have an impact downstream. This is where a lot of our water comes from. There's good reasons. There's lots of social pressures, political pressures on why we'd want to focus on east slopes and foothills. These areas also have fairly different pressures from an anthropogenic perspective, but also natural disturbance. There's wildfire everywhere. If you're not familiar with the province of Alberta, there's Calgary, and there's over 1 million people in Calgary, and a lot of them have things that they like to go into the forest and recreate with. So there's a fairly significant recreation pressure on our watersheds in southern Alberta. We have cows. I think we have a lot of cows, and a lot of them are in southern Alberta, and a lot of them are grazed in our forests. There's, to a lesser extent, there's some forestry happening in that part of the world. And wildfire, there's recent history, there's been some significant wildfires. In the foothills, although the price of energy is a little bit lower, there's still a very heavy industrial footprint as far as energy development, forestry development, and that type of work. This sort of pine breadbasket of Alberta, plus apparently there's some energy reserves underneath there that we like to use, primarily gas. So if we kind of break this down into this system that we have, thinking of these two areas, trying to look at sort of office and detailed approaches. So this is a map that we produced with Mike Wagner in Dutch Creek, actually. So this is sort of the headwaters of the Old Man, using some of the tools embedded within Lee Benda and Dan Miller's products. And in this case, it's building off of a U.S. Forest Service product. The acronym's GRAPE, and I can give you that information in the future. We look at riparian processes, this case being sort of an on-the-ground detailed process. I won't get into a lot of the details because of the higher level stuff that we've been looking at in conjunction with the Forest Management Branch, because Dan has sort of talked about some of that stuff. And then the hydrology processes. Really what I wanted to focus on in this presentation was this idea of the riparian stuff. But before I get into that, I just sort of wanted to highlight what the relationship between what we're doing and some of the stuff that Dan Miller and Lee Benda, and sort of how they're pulled into some of this as well. So we've really, using that idea of end members, here we have the natural regions again in slightly different colors, and we also have the superficial geology. So we have one sort of end member that we're using as an example where we tried NetMap in the Old Man, steeper, a little bit like Montana in the US where these tools are based off of. And then we have Grand Prairie in the Simonet, not like Montana. So really trying to determine how these things work. One of the things that we've done, especially in the northern area, which I think was talked about a little bit yesterday by a few people, was again digging into these processes. So roads, what are we doing with roads? Unfortunately, as far as I know, remote sensing can't tell me the difference between that culvert and that culvert. So we tend to have to still go out and assess these. We sort of ask some questions around fish passability. What does this mean? This actually came out of a mountain pine beetle project where I think we asked the question, should we be reforesting to help fish, or should we be pulling culverts? Apparently that wasn't very exciting, but the research that came out of this was still very interesting and useful to others, I hope. Apparently when we were doing this, there's also something else that roads do. Roads have surficial erosion. There tends to be fine sediments and things. So we got a new student who's going to start up looking at some of the tools embedded in the NetMap stuff. Hopefully, fingers crossed, I'll have a student in the south and a student in the north sort of looking at whether or not the U.S. forest tools that are embedded in Lee and Dan's product, the NetMap, are working properly for our environment. So jumping back into what I said I would like to talk about right now is really the riparian assessment. So this is a project, unless you've been under a rock or not in Alberta, there was a few floods in 2013. And they impacted the southern part of Alberta and primarily Calgary. And there's been a series of initiatives that came out of that. One of them was this watershed restoration program, resiliency and restoration program, where they're emphasizing sort of soft touch, more natural capital investments in either droughts or, in this case, floods. So one of the proposals that we put in was a riparian assessment proposal to really look at how the floods, but also other anthropogenic, so cumulative impacts associated with the riparian health associated with southern Alberta, Bow River Basin South. We're building off of older systems, sort of based on those initial examples that I showed you earlier, and really asking some of the questions around whether or not these approaches are applicable to Alberta, and then from the government partnership, collecting some data that they're going to use as well. So we're really after, are these appropriate systems? Are they working well? Is it well calibrated to Alberta? Or do we need to do some tweaking to these systems to make them work? They're a fairly simple method. You send a crew out that answers a bunch of yes-no questions. If you're familiar with sort of the cows and fish program or other types of things, this would be a very similar one, just tailored to forest environments. And in particular, we stole the one from BC. Or I shouldn't say stole, right? We adapted the British Columbia system. So we brought in their consultant who trains their people that showed us how to use it. And our intent is to refine that based on the data that we collect. So again, borrowing another sort of sample design, Mike Wagner, who really put this together, developed a stratified random sample design of where we would go, we figured that 2 kilometers within a road was a reasonable distance to ask our field crew to walk. We don't have a lot of that field crew wishing to return, which, anyway. And one of the things that you note in here is we had a lot of sites we wanted to visit. There were some funding issues. We didn't get the funding till later, so it was a bit of a late field season. But access was an issue. So if you ever want to do sort of flood assessments and you want to rely on your roads in an area that was heavily impacted by floods, don't rely on your roads to be there. And also budget for additional damage to your field vehicles as your field crew tries to get into the places where they think they should be. So yeah, a lot of flood damage to the infrastructure, to the roads, to the trails, to those type of things. So that was one of our biggest unexpected challenges in actually getting into these areas. So we didn't get as many sites as we had hoped done, and we do have another field season planned for this coming season to pick off some of these. So getting into some of the results associated with this one quickly. This really puts it into bins. So if there's 0 to 2 no's, we assume the area is properly functioning. If you get all the way down to more than 6 no's, something's not working right, then we assume that there's problems associated with this. So if we put this up, really what we've found is things are not in great shape in this part of the world. The data and the way that we collect it allows us to kind of dig into what's going on there. One in particular, which might be of relevance to a lot of the sort of forestry people, is the Ghost River pops up as something that's having a few issues. So one of the problems that we've also run into is we stratified based on distance from road, primarily because we're looking for areas that do have some sort of anthropogenic footprint. If it's more than 2 kilometers from some sort of access, people aren't necessarily going there. There isn't forestry happening. There's a lot of parks in this top end, but also access issues. So we really haven't been able to sample some of the more isolated or pristine areas. So our sample set is skewed to the area that is under more management and, in this case, impact from recreation. One of the things that we can do is actually dig into why are those things being called no. What is causing the issues associated with our riparian areas, and is there sort of a cause and effect that we can glean out of this in this idea of cumulative impacts? So these are what Mike has done here. Is just gone through and pulled out the questions that score high as far as number of no's. So are the channel banks intact? Well, there was a lot of no's. We haven't dug into the data to figure out why, but given that this was an area severely impacted by some floods, that could be a very good guess. Again, our large woody debris or large wood associated with the channels, are those processes intact? Again, that was another one. Probably not, because in the 1950s they were pulling all the wood out, but again, because of some flooding and some other issues in this part of the world. Moss present on the substrate, so this generally would assume if you've got big rocks with moss on it, it's a stable system. Again, big floods that have gone through there. Fine sediment, something that we've been working on because anecdotally we've thought this has been an issue in these parts of Alberta with lots of roads, lots of recreation has come up. Erodible ground and soil disturbance. Is there any cattle people around here? More often than not, we have to QA/QC this, but this tends to be related to cattle issues, and in some areas recreation use. People and cows tend to like water, and people with quads tend to like water as well. And then, has sufficient vegetation been retained at the site? So, again, whether or not there's any issues associated with vegetation change. So the next steps associated with this quick project here, we need to finish off the sample design or the sampling associated with this. Again, find a new field crew that are willing to walk up to 2 kilometers, and sometimes a bit of a challenge. Although the price of oil going down, you find there's more people willing to walk for a paycheck. And then sort of calibration of the tool. So really what we're after, these things are borrowed from BC or other areas where there's coarser soils, a little bit more wet water. We're finding that some of the thresholds associated with percent fines, we're also sampling areas that are quote unquote pristine, that we would like to use those to find those benchmarks. So in certain areas in BC, if it has 5 to 10% fines, it would be considered not properly functioning. In our case, we're assuming that's higher because we have finer soils. We have more fines in our stream systems in general. as far as fine sediment. And also trying to actually dig into it to try and figure out exactly what's going on and some of the more Alberta specific categories. I noticed Mike has put grazing down here. I would argue that that's probably not just Alberta specific, given that a lot of these have come out of the USDA and Montana. Apparently they have lots of cows too. Oh, and I wanted to put this up here too because this concept of looking at different natural regions or different areas where we have different hydrologic processes. West Fraser actually ran the very similar process on their FMA for a completely different unrelated exercise, but we're hoping to partner with them to access their data, which is in our blue smudge. So not the purple smudge, but the blue smudge, to really be able to round this out to say, not just look at the eastern slopes and calibrate some of these things, but also whether or not we can apply this in the foothills in a reasonable way as well, and whether or not these things should be different. So just sort of a recap of kind of circling back around. This was supposed to be broadly about assessment procedures and cumulative impacts and how we deal with that in forest environments in Alberta. I just wanted to show this slide to sort of recap and say we're looking at sort of large processes that we can run in the office and in the field based on these bins. So again, erosion processes, riparian processes, and hydrology, and the linkages between them. Really trying to capitalize on lots of really good data sets that we have in Alberta that maybe others that aren't in Alberta might think it's not fair, but I don't really care. We have LiDAR, we might as well use it, we might as well try and make sure that that's improves our efficiencies so that we can kind of close that gap between the office and the field. The other big one I wanted to emphasize is this idea of process science. So actually going out and understanding how the processes, whether it's groundwater, surface water interactions, in this case, one of Aldous Sellens' sites that we have a PhD student working on now, looking at what happens as pine forests die, in this case simulated dying, and how that relates back to what we know about change in hydrology with sort of site-specific, regionally based science to be able to inform this process. Most of this is opportunistically driven. Where there's a problem, generally where there's funding, it's pretty hard to get a graduate student to work with no funding at all, even if the price of oil is really low. So although there is sort of a broader strategy, we are working based on where we can find funding and where we can work towards. One thank you, and then just sort of a general note, I haven't listed names, but just it's still important to have people go out and do research and measure things and stuff like that.